Colligative properties are the properties which depend upon the number of particles of the solute relative to the number of particles, total number of particles in the solvent, a solution, are known as colligative properties. We have learned about what is colligative properties, and the colligative property is independent of the nature of the solute particles. It may be any particle having any composition, any structure, but it is the number of solute particles and also the total number of particles in the solution that is present relatively is known as colligative properties. And we have seen that the elevation in boiling point, depression in freezing point, or lowering of vapor pressure, including the osmotic pressure, results into what is known as colligative properties. These are known as colligative properties. Now today we shall take up some details about relative lowering of vapor pressure. Now what is meant by relative lowering of vapor pressure? We know that vapor pressure is lowered or decreased when a solution is prepared. The vapor pressure of the pure solvent is represented as P1 naught, while the vapor pressure of the solution, which is lesser than that of the pure solvent, is known as P1. This is just a notation. And P1 naught minus P1 represents only the lowering of vapor pressure. But we are interested in relative lowering of vapor pressure. Now, this relative lowering of vapor pressure is definitely a ratio which is P1 naught minus P1 upon P1 naught. And obviously, P1 naught is present in the denominator, and this is equal to mole fraction of the solute in the solution. What is mole fraction is known to us, that is the number of moles of the solute upon the total number of moles of the present in the solution. That is the number of moles of the solvent plus number of moles of the solute. So it is N2 upon N1 plus N2. Now, if we consider a dilute solution, we find that N2, that is the number of moles of the solute, is much less than N1. ये बहुत कम हो जाता है. So therefore, to this extent, we can ignore N2 from the denominator here. And therefore, our expression turns over to P1 naught minus P1 upon P1 naught is equal to N2 upon N1. And we know that number of moles is equal to weight divided by the molecular weight. If Wp is the weight of the solute and molecular weight is represented by capital letter M2, similarly, if W1 is the weight of the solvent and molecular weight of the solvent is M1, therefore we can substitute these values and we get W2 upon M2 divided by W1 upon M1. And on simplification, you get it equal to W2, that is weight of the solute, into molecular weight of the solvent upon M2 into weight of the solvent. So that is there. So this is one of the expression by which we can find out the lowering of vapor pressure. Very important and has to be kept in mind.
Molecular weight of the solute can also be calculated using this expression.